Good morning, good afternoon, good evening. Welcome to dclessons.com. Today we are going to present module 8, Nexus 7K VDC types. So in this topic, we will learn about the VDC type, what is the default VDC, non-default VDC, admin VDC and storage VDC. What is the use of default VDC and non-default VDC? What is the difference between default VDC and admin VDC? And how we can create an admin VDC and what is the significance of admin VDC? So let's talk about the default VDC. Default VDC is the VDC which is supported on Nexus 7K only, right? When we reboot your NXOS device or when we first time log into it, we lands up into the default VDC. And all hardware resources of the switch by default belongs to default VDC. And the default VDC has a ID 1. So what is its features? Default VDC has a ID 1, right? Default VDC acts as your boss, like it is used to create, delete and manage another VDC. Default VDC cannot be created. Via default VDC you can allocate port to non-default VDC. Default VDC can be replaced to admin VDC, and which is applicable only from Cisco NXOS 6.1 version, right? And default VDC can be able to interact with another VDC via management plane, right? So it is NXOS 6.1. Now system-wide parameters like COPP, NTP and another configuration can be configured via default VDC. From the default VDC you can manage or install licenses. Once you can once you reload the default VDC, entire switch can also be reloaded. So please make sure before reloading to default VDC, make sure that you have taken proper downtime and you have a good reason to reboot it. Otherwise your entire switch or chassis will be rebooted and you will face a downtime and can face a heat, right? Default VDC can also be used for APLD upgrades, and it can also be used for ETH analyzer captures. So we can say that default VDC is just like your network boss of your switch, through which you can create, you can delete, you can manage, you can allocate ports, you can configure the system-wide parameters, license management, everything you can done. It can, you can do it via default VDC. Now, what is a non-default VDC? Non-default VDCs are those VDCs which we generally create, right? And non-default VDCs are mostly used in a daily production traffic. So let's suppose that you have a company. There you have 3 or 4 departments. Now generally what happens that you need a distribution layer switch or a core switch for each and every department. But if you have a Nexus 7K, you can create a logical switch, right? You can create a VDC, a non-default VDC, and you can allocate that non-default VDC to your particular departments, right? So even though you are using or you are investing on only one chassis, but you are using 3 or 4 non-default VDC based on your licenses and based on your supervisor, and it can act as a core switch or a distribution switch for that particular department. So this type of VDC is said to be fully functional and it has all capabilities. You can do anything you want and just treat it as a separate switch, right? Any changes that is done on any non-default VDC will be applicable to that VDC only. It will not replicate to another VDC. Why? Because each non-default VDC has its own configuration file. Non-default VDC has its own configuration file. You can also create a checkpoint, right, which can be used per VDC in the non-default VDC. Non-default VDC has its own set of L2 and L3 protocol, right? Thus it provides a fault isolation. So as I said earlier in our module 7, that each VDC will have its own L2 and L3 processes, L2 and L3 configurations. It has its own rib and MAC table like that. So non-default VDC is mostly, it's not mostly, it's always be used for your daily production traffic. So what do you understand by admin VDC, right? So So let's understand why admin VDC came into the picture. So let's see a scenario that you are using a Nexus box where you are using a default VDC plus three non-default VDC. Where for three non-default VDC you are having a finance, you are having a sales, you are having HR, right? And in those departments their respective application servers and user sets, and you are using three non-default VDC. Later on another department came into the picture, which is we say as a marketing department, but you are using a soup 2 with one advanced service license. So there we can only create one default VDC plus three non-default VDC, and that means your maximum limit has been reached. You cannot create a non-default VDC. Now let's suppose a new department came, marketing department, and you want to install a core switch, Nexus core switch. I mean the core switch which has the functionality of Nexus. How you will do that? So in this scenario, either you have to upgrade your supervisor from soup 2e to soup 2 to soup 2e, and then you have to upgrade your license also. That requires a cost. So then what is how we can do that? So in that case we can use our default VDC. We can replace the default VDC to the admin VDC. As soon as we will replace our default VDC to the admin VDC, I can get a bandwidth of one new VDC. So I can create one new VDC, and that new VDC I will create and I will allocate it to the marketing department. So I am using the same supervisor, I am using the same license, but I got capability to create one more VDC once I replaced my default VDC to the admin VDC. So this is the benefit of using admin VDC, and believe me, admin VDC works as the default VDC, but it has some uh, you know uh, uh, restrictions. Let's see what are those, right? The purpose of administrative VDC, admin VDC, is only for administrative purpose. So if you want your VDC to administrate all other VDC, then why should you need the Ethernet ports, right? So in the admin VDC, you have only a management port at its member. No other port will be its member. Why? Because there is no logic. I am using the admin VDC for my administrative purpose only. So in that case, only the management port will be a part of that VDC. No other Ethernet port which is used to connect your server, your other network devices or users will be a part of admin VDC. While creating admin VDC, you need to allocate all the ports to all other VDC, right? So that your admin VDC can have only a management ports as its member. Now let's see what is the benefits of admin VDC. Admin VDC is purely used for administrative purpose, COPP configuration, VDC creation, suspension, deletion, interface allocation, everything is done by admin VDC, just like default VDC, port channel configuration, VDC level security, right? Every module controls can also be achieved by admin VDC. Admin VDC can also manage the license, right? See, the purpose of admin VDC is used to administrate the VDC, and it has only a one port we say as a management port, and that management port can be used for out of band management. So in that case, there is no use to perform any L2 or L3 configuration or L2 or L3 protocol like STP and other stuff. Why? Because you only have one management port. So in admin VDC you cannot perform L2 and L3 features including routing protocols, but admin VDC has a very limited feature support like NTP, password, privilege management, SSH, TechX, Telnet. So all these protocols are used for management purpose only. So that is why admin VDC has a very limited support. Once admin VDC is created, it can be deleted, but it cannot be changed back to the default VDC. So make sure before deleting your admin VDC. From NXOS 6.1, your admin VDC can be enabled, right, on SOUP 2 and SOUP 2E. Earlier, only SOUP 2 and SOUP 2E has support, but now from NXOS 6.2.2 SOUP 1, you can use SOUP 1 also to create, admin VDC. Okay, so this is the benefit of admin VDC. Make sense? So now you will be able to uh, correlate or differentiate what is the difference between admin VDC and what is the difference between default VDC, why admin VDC came into the picture, what is the significance and benefit of the admin VDC. Now let's see how we create admin VDC. So admin VDC can be created by three different ways. First ways is, if you are using a pure new Nexus box, greenfield, you purchased the NXOS box, right? You came, take it to the data center, powered in on, and you connected a console. So as soon as you connected a console, it will ask for a basic initial configuration. There only it will ask that whether you want to create a default VDC or admin VDC. If you say yes, so here it will ask, do you want to create admin VDC? If you say yes, your admin VDC will be created. Right? Else, if you say no, your default VDC will be created. You will be a part of default VDC now. Second step is, let's suppose you created a default VDC, but your default VDC is not being used for any production traffic. For any production traffic. In that case, you can replace the default VDC with the admin VDC via system admin VDC command. You just go to the default VDC, write this command, your default VDC will be replaced with the admin VDC. But while doing so, all non-global configuration of default VDC will be erased or removed. So second option is used only when your default VDC is not used for production traffic. Make sure, then only you can use the second option. Now the third option is, what if you are using a default VDC for some of the production traffic, not have on a large scale but for a small scale. In that case, if you use the second option, your non-global configuration like interface configuration and other stuff will be erased, and if any production traffic is going through that VDC, that can be hampered and you can face a disconnection and a downtime. So how you do that? In that scenario, you need to write this command, admin VDC migrate and new VDC name. So what will happen? Let's suppose you created a new VDC name like XYZ. So while doing a step third command, what it will do, your default VDC will be created to admin VDC. Same time, a XYZ new VDC will be created, and all non-global configuration will be shipped to new VDC from the default VDC. Right? So this options so while doing step third, or while performing The step third, you can save your non-global configuration, right? And this step can only be used when default VDC has been used for production environment. So there are three different methods to create an admin VDC based on your choice of environment, right? So this is how you can create an admin VDC via using three different methods. Whether it is a greenfield, whether your default VDC is not being used for production traffic, or third method is if you are using a default VDC for production traffic. So let's see what is a module type. So module type is a very interesting command which is used when you want to restrict your VDC to use a particular set of line card, right? So if you want to restrict the VDC to allocate certain type of module ports, you can use module type parameter, right? So if you use module type parameter with M1 command, what it will specify is it will specify that VDC can contain only M1 module port. If you use module type with F1 command, it will say that my VDC can only contain F1 module type ports, right? So this is the full command, limit resource module type. So let's suppose you configured a VDC XYZ, and under it you wrote this command, limit resource module type F1 M1 and M1 XL. Here you are saying that in my XYZ VDC I can have only M1, I can have only F1, and I can have only M1 XL module ports. No other module ports will be allocated to your VDC XYZ. Okay. Now, if you allocate a conflicting module, so let's suppose you limited this XYZ VDC with F1, M1, and M1 XL, but you tried to allocate, F3 module port. So what will happen? This module, F3 module, will be put into the suspended state or OIR state, and due to which you will not be able to allocate the interface, or you will not be able to configure any interfaces of this module, F3 module I say. And an important point to note that F2 module cannot be coexist in same VDC with non-F2 module. So if you want to allocate F2 module, you only have to allocate it F2E and F3 module. F2 module is not supported on M1, F1, M2, M1 XL. These are not supported, only these are supported. If you have any port of F2 module in a particular VDC, then in that VDC you can only allocate a port of F2E and F3 module. So please make a note of it. Now, resource allocation in the VDC, as we say that we can also restrict the resources allocation. So let's suppose I want to have a VDC, right? And I don't want my VLAN number should exceed from 10 to 100. So maximum limit is 100. Till 100 number of VLAN I can configure it. After that it will give me error. Or let's suppose that I can only be able to configure the VRF from 2 to 10. So maximum number is 10. I can only configure 10 VRFs in my VDC. So that can also be done, right? So resource allocation can easily be done on a VDC, and by default this is the default resource minimum and maximum range of resources. Even though if you don't configure explicitly, these limits will be applicable to VDCs. So just like if you want to, if by default IPv4 unicast route is 8 MB, 8 MB, right? Port channel 768 is maximum limit. VLAN you can configure 4094. Span session you can have maximum 2. VRF you can have maximum of 2096. eSpan you can have a maximum of 23 span session you can configure. But these are the default allocation. You can use the limit resource command, right, to modify these minimum and maximum limit, and then you can and then you can configure it under your VDC. Now resource utilization. So in this section we will see how the resource utilization is done at layer 2, right? So in general, what happens, the forwarding engine of each input output module learns the L2 MAC address and maintain its copy, its local copy in its local forwarding L2 local forwarding table, right? So each module will have its own MAC table and it will contain the MAC address entry, correct? Now this is the default behavior of modules, right? Now once you are configuring a VDC, this behavior changes. So how this behavior changes, so let's suppose this is your module 1, this is your module 2, and this is your module 3. Now on module 1 you allocated 1 by 1, 1 by 2, 1 by 3 on VDC 10 and 1 by 4 on VDC 20. So on module 1 there the ports are allocated to the VDC 10 and VDC 20. On module 2 one port is allocated to VDC 30 and rest port is allocated to VDC 10. On module 3 one port is allocated to VDC 30 and rest port is allocated to VDC 40. So here VDC 10 is not available, right? Now let's suppose you connected a computer, right, and that has a A MAC address A, right? So as soon as the host is connected to the port, it sends its MAC address information to the switch. So switch will have a MAC A in its MAC table. Now as soon as the line card will have the MAC A in its MAC table, what it will do, it will save into the its local forwarding L2 forwarding table and it will advertise that MAC entry to switch fabric. Switch fabric will send that entry to line card 2. Line card 2 will see that okay, I have the VDC 10 instance available, so that will install MAC A in its MAC table. But as soon as fabric will send a MAC A information to the module 3, module 3 will see that I doesn't have any VDC instance or I don't have any ports allocated to the VDC 10. So in that case it will not install MAC A in its MAC table. So this is how MAC address table is populated when you are using a VDC context. Okay, and by this feature you can very well utilize your resources, correct? Understood? Now let's see how the layer 3 resource utilization is done, right? So what happens in general, I mean, if there is no VDC configured, so if there is no any VDC is configured, TCAM table on all input output module contains the same set of routing and access entries, right? So if there is no VDC, all the line card will have the same TCAM table that contains the routing information and access list information. Now if you configure a VDC and allocate ports of input output module on VDC, then the hardware resource utilization can be improved, right? How it can be improved? It can be improved in a such a way that you should avoid combining ports of module which have high number of routes and access list. So let's understand this by example, that if you have a VDC 10, right, and you allocated module 1 and module 2, and the VDC 1 has a number of routes 10110k and ACL has a 50k. Likewise there is a VDC 20 which is also contains the ports of module 1 and module 2. It has the number of routes 100k and the number of ACLs 20k. A VDC 30 has a module 1, 2, 3, 4 and it has the number of routes 10k, 20k ACLs. Likewise, VDC 40 has a 90k and a 40k as a number of routes and ACLs, and it contains the ports of module 1, module 2, and module 3. Now, so this is the exact, I mean, you did the VDC configuration, you allocate the port module, and you receive the number of routes and number of ACLs as per your TCAM entry. Now, how you can best way, or how you can better utilize your hardware resources? So in that case, we can see that we should avoid module, I mean, VDC 10, VDC 20, and VDC 30. Avoid combining VDC 10, 20, and 30 together. Why? Because VDC 1, VDC 20, or VDC 30 itself has a highest number of routes and number of ACLs. Instead, what you can do, you can combine VDC 10 and 30. So VDC 10 and 30, you will have 110 plus 10 number of routes, and 50 and 20. You can either combine VDC 20 and 30, and you can either combine VDC 30 and 40. And what do you mean by combining VDC 10 and VDC 30? The ports, right? So once you do in a such a way, then in that case you can achieve your layer 3 resource utilization in a proper manner. So by using this method, you can improve your hardware resource utilization for a layer 3 resource. Make sense? So thank you for watching module 8 Nexus 7K VDC type.